Hey, good to see so many people here. Very excited to talk to you guys. I'm Abram Jackson. I'm a program manager for high availability, site resilience on the storage team. My manager is right here, a bunch of my team members. And this is Tim.
Hi, I'm a senior support escalation engineer from our Charlotte support facility. My manager's not here.
So we're going to talk to you today about high availability and site resilience. In Exchange. Yeah, that wasn't on the session title, but that's what we're here to talk about. So if you hear about Azure high availability, you should probably go find another session. Hello. So this is the team that brings you high availability and the database engine in Exchange. Both Exchange Server, this is the engineering team, and Online, this is the operations team. Exchange Online uses a DevOps model where we don't have operators except for us, the engineers. So all the people that you see on this slide, several of them are presenting this week, and some of the others are sitting here in front of me, are the people both running the service and developing the features to enable you guys to run Exchange like a service. Exchange Online has more than 1 million database copies, and we don't have people to go manage them for us. And so we are building the features and giving them to you guys so that the things manage themselves. And that goes into our cloud training. There's this quote by Bruce Lee: "I fear not the man who's practiced 10,000 kicks once, but the man who has practiced one kick 10,000 times." If you practice something over and over and over and over and over again, and you constantly get better and better and better at it, you're going to get very good at it, obviously. And so that's the way we feel when running the cloud, running Exchange Online. Where we did 3.5 million database failovers last month. I know everybody already talked about all these numbers. They took them from this slide. But we also do several upgrades of the entire production environment, just like you guys have to do cumulative updates every quarter. We have hundreds of servers fail every month. There's multiple servers failing every day, so we need to handle all of that automatically. It's practicing that kick over and over and over so that the database fails over and that customers don't notice the impact.
So what we're looking at here is the typical Exchange 2013 architecture. In Exchange 2016, as most of you have heard, this is actually going to be collapsed, so you won't be able to actually split the roles anymore. Oh, no mic? Hello? Hello? There we go. Hey, it helps if it's turned on. We utilize in the service, and we recommend both on-premises through the preferred architecture model, that you use kind of a horizontal, scaled-out approach that leverages the database availability groups to have your continuously replicated database copies. Oh, check that out. There's a new animation that actually squads those things together, so you can see that the roles have now collapsed. The user mailboxes that you provision are subsequently stored in these databases, and any time user processing requests are submitted, whether it's a client request, whether it's a transport request, or a move mailbox, anything that's going to interact with that database, those requests are actually sent to the server that's responsible for hosting the active copy of the database. And as those databases move or are failed over or switched over between those hosts, the responsibility for that processing changes between them. So, by running in the service, we're able to actually deliver a better product on premises. Okay? Our number one priority is to give you a stable platform and to take what we've learned in the service and bring it to you through availability that is automatic and simple. And what we're going to do as we proceed through the presentation here is we're going to align the content and the things that we talk about to these 3 points: automation, simpler, and high availability, again, all derived from what we've learned in the service.
All right, so automated. Of course, with our 15 engineers running more than 1 million database copies, a lot of things need to be automated. And so we build the code that automates things, and then we deliver it on premises. And now it's not every single part of our automation that you'll have on premises, because most of it doesn't make sense. Well, not most of it, but some of it doesn't make sense, and we try to get as much of it into on premises as possible so that you guys can run your service as hands-off as possible. Now, don't expect that everything is going to be automated and it's just an appliance. You still have a job and there's still a lot of management to do. But we try to make it as easy as possible for you. The first part of that is failed hardware, where in the service, things are failing all of the time. So here's the 500 servers failing a week or whatever it is. So you can see, we've got disks failing, we've got controllers failing. That's 500 disks a month approximately at our current scale. I think this is for last month. Actually, it's March. And so all of these things are handled by database failovers. So when there's that many things failing, we needed a mechanism to be able to prioritize just exactly what's failing. I'll tell you a story about, we received a bad batch of hardware that had its BIOS configuration settings wrong, and then there was a bug in the firmware such that most of our servers in all of our new capacity started to fail when they started getting under load. And so this isn't something that we're able to notice until we got them under load, and so it happened live in production. And this is the sort of thing where you've got lots of servers failing, and you need to be able to pick which one is you're going to work on. Let me zoom in here. So if you run the command git mailbox server redundancy, you'll get output that looks a little bit like this. Of course, it's PowerShell formatted, not Excel formatted. And the two major columns here are repair urgency and safe for maintenance. You see the values here under repair urgency are whether they're important, whether you should get these fixed sooner or later. So you can see that there's critical, high, and normal for repair urgency. We'll go into detail about what each of those mean, and there's also prohibited. So basically, you want to repair the servers that have unhealthy copies of your databases, because that's going to bring the database copies back online. However, if it has the last copy of your database, you don't want to repair it. You don't want to shut the power off, because then you just caused an availability. You just took down that database, or you've lost your redundancy, depending on what you're actually fixing, and then you're going back in time. The safe for maintenance is sort of the opposite, although it is related. So think of safe for maintenance as it's all right to bring this down for something that might break the server. So even in this terrible situation that we were in, fortunately I took this screenshot from dog food, there's some servers like server A7 that is totally fine to upgrade. Even though you're in this nightmare scenario, you can go ahead and upgrade to CU7 on server A7. Now, of course, we didn't because we were prioritizing working on that repair. So each of these things are handled by or included by these other things. So if something is critical, listed as repair urgency, that means it's either critical for restoring availability or critical for restoring redundancy. So if it's in either of those conditions, you should not be taking it down for repair. If there's another database on the server that you can repair without bringing other ones down, you can go for it. So critical for maintaining redundancy means that this is holding one of the two redundant database copies. So if you were to take this down, you would be down to a single copy of your database that's up to date. And then you're at risk of a single disk failure. That's when we alert. That's when we get the phone calls, and that's when you get the event log that hopefully is alerting you as well. Critical for restoring availability is bringing up if this is the server that has the only available copy of some database. Or for restoring availability, it's the server that has the second available copy of the database. So this will bring it up to a second available copy. And so there's a little bit of mismatch between redundancy and availability because we view redundancy as more important. If the database goes down for a little bit, it's not as serious of an issue. So this is it's basically -1 for availability. And then on the other side, there's for maintaining availability and redundancy, which applies the same way. If it's critical for maintaining redundancy, that means that for redundancy, it has one of the two copies that is actually up right now. And so if you were to bring this down for maintenance, you would be bringing yourself into one copy. And the same applies for availability, where it is the only available copy of the database. There's also high. High for restoring availability, high for restoring redundancy. This is basically add 1 to both of those other things. So for redundancy, this is bringing up the fourth redundant copy of the server or of the databases, or bringing up the third available copy of these databases. Now, it's only since we don't want this to go off for a single disk failure that hopefully auto reseed is taken care of. It's only high for restoring redundancy if it's at least 5 databases. So we're assuming that you're using preferred architecture with 4 databases per volume. So anyway, I saw all of you glaze over in that detailed explanation. So focus on the first 2 columns, and you can just believe me that it makes sense. So how do we do this in Office 365? If you went to Vivek's Behind the Curtain talk a couple days ago, you'd know some of this, but I'm going to go into more detail. We have this service called RepairBox, which basically does our hardware diagnostics. At least every day, it goes to every server in production, in a scale-out way, and looks for errors. Now, this can be an out-of-band management through whoever your provider is. It can be through Windows Event Log, or it can be specific diagnostic tools that we've written for each of our vendors. And when there's a failure, it identifies what the problem is based on our logic and tries to fix it. And then if there's a software fix, perhaps rebooting it or something like that, or changing BIOS config, or it opens a site services ticket for someone to go replace that physical hardware. And so in most of these cases, there isn't somebody that needs to go figure out what is broken with this server because we've built this logic from our massive pile of servers and running them. So I mentioned that there's events that we write. And so this is the part that applies from the cloud back to on-premises. So these are events that the high availability or the Windows processes write to their system event log, which we think are good ones for you guys to look at, to pay attention to whether something is already failed or about to fail, and you need to open your own site services ticket, or if you're in a small enough shop, go replace the thing yourself. So the brand new ones for Exchange Server 2016 is write latency, where if the server has high write latency, this is over 100 milliseconds total over 24 hours, we'll have Microsoft Exchange High Availability will be the event source. The event ID will be 387. And so you guys should be watching for that one, and that means your controller is probably broken. If there's multiple disks failed on a server, we've seen controllers report they're totally healthy, but it wasn't their fault that all disks failed simultaneously. So don't believe your controller hardware when it tells you that. If there's more than 2 disks failing at the same time, your controller is probably busted. Replacing those disks isn't going to get you very far. We've also got, since their database engine is so close to the hardware and so optimized for these spinning disks, we've got predictive hard disk failure also writing events. So if you see event 389, that means all of the databases that you put on this disk, if you put multiple database copies on this disk, are experiencing high latency. That means this disk is not performing well. You're going to want to replace it. Make sure you've got good availability with the redundancy API and get it replaced. Same thing for bad blocks in multiple, if it reports different blocks broken on that disk, it's probably going to fail soon. And there's also ESE performance events. So these will come from the ESE source, events 532, 33, 509, and 510. If you see multiples of these, that's another good indication that this disk is about to go down. Okay, so how does RepairBox specifically work when a disk fails? So if that blue disk is the active, and if it fails, of course we do the database failover. That's high availability. We've had it since 2010. We do it a lot. We're very good at it. And so that restores the user experience. Auto reseed restores your redundancy. So it brings up that 4th copy of your database. And so then it's the process of actually getting that disk replaced. So that's where in the service we have automated checks. We're checking our vendor-specific storage APIs to run the test. Here it found out that it's failed, and it is going to open a new site services ticket. So here's ticket 0365, disk failure detected. This is coming from the vendor-specific stuff. It basically tells a person, this server on this rack, in this bay, on this slot, go replace that disk. And this is assigned to a person, our Carbon-based system, who takes maybe a week to go replace that disk, because that's all that's necessary with these hot spares. So as long as another disk isn't failing, we still have full redundancy for all of our database copies. So you can apply a very similar process to your own on-premises environment. Obviously, you don't have the repair box, but you can build a similar thing watching for event logs and opening hardware tickets. And then the rest of it is taken care of. Oh, and the last part, once the disk is replaced, you'll need to have it initialized, online, and reformatted and put in Exchange volumes so that it can be used as a new spare. All right. So maintenance is the next process where we release cumulative updates every quarter, and we're making it as easy as we can for you guys to be able to apply those quickly.
So one of the things we kind of combine here with the maintenance topic is the topic of maximum preferred active databases. So we give you the ability across a DAG to specify the maximum number of databases that can be active on any member of the DAG at one point in time. And this is very helpful because when the DAG is under full load and it's actually healthy, this ensures that when you issue your moves and the databases are being moved by Active Manager across the DAG, you don't put yourself in a position where one server ends up taking on a majority of the load versus the other ones. So an example of this, we've decided that we're going to perform maintenance on these two servers. So these two servers we're taking out of rotation for some reason. You can see the databases have moved to the alternate hosts, and those will now be distributed. If we move forward with taking further servers out of maintenance, then you can see that those databases again are shifting, and right now the load is fairly distributed. So if we look at node 3 and 4, we've got 3 databases active and 3 databases active. And same if we take a look at the other side, right now it's 2, 2, 3, 3, 2 is where we're sitting right now. So at this point the load is fairly distributed across all the members of the DAG. If we proceed on with removing servers from the DAG or taking them down for some reason, the databases will continue to distribute amongst the hosts. And again, what we can see here is that the split has now started to even out a little bit more. You have 3, 4, 4, 2. And when we take down the last node, node 4 here, oops, too many clicks here, I apologize. Can you back that up for me? I can't seem to get the clicker back up.
Yep.
Whoops. So if we were to drop node 4 right here, what would happen is that those databases could be unevenly distributed. So what we would end up with is we would end up with node 1, 2, or 3 potentially having more than node 4. So the load would not be evenly distributed in response to this. And what max active databases is going to do here is if we were, for example, to set max active databases at 4, it would force one of the other databases to move over to the 4th node in the remote site. So that way, we're getting that even distribution of load across the service. And I believe right now we set 21 max active databases per server?
Yeah, max active is at 21, and then you've got max preferred active databases, which helps you balance it out at 14.
Yeah, thank you. Now, what's also really important about this is that really the only time that max preferred it comes into play here as the databases are transitioning between nodes is when everything is healthy. Okay, so we do not necessarily use this to override your best copy selection. So if there's a particular node that is at max or coming near max and it has, for example, a failed index, we will still go above the max preferred actives to bring that database online on a server where the index is healthy. So really you can only count on the max preferred active databases kicking in and being effective when everything is healthy across the DAG and all copies are equal at the time. So best copy selection will still ensure that your databases are going to a server that will provide you the best redundancy and the best client experience. There we go. So along with this too, we now give you the ability to make policies that limit the administrative moves that can occur across a DAG. And one of the things you can have here often, especially in the service, is the potential for too many chefs in the kitchen. So you could have somebody who's saying, I'm going to be upgrading a server. You have somebody else who's going to be dealing with a failed disk. You have somebody else that's dealing with a failed controller. So administratively, you might have people actually going through and moving databases both manually, and then at the same time, you still have the solution that's actually responding to failures. So what we're giving you the opportunity to do now is actually specify a policy that says there's peak times, for example, where administrative moves will not be allowed. You actually have to override it if you want to make a move. These policies, though, do not affect failures. Okay, so even if you were to set a peak time that you want it to actually be able to move a database or block database movement, if there was a failure encountered at that time, Active Manager will still move the database. I'm having an awful time with the clicker. I'm sorry.
Okay. I'm go through the animation and skip it.
Thank you. Huh? Point that way? So again, right, you can see here when we kind of go through the spectrum, you might have somebody, again, who's responding to a disk failure, somebody who's saying it's time to upgrade the actual binaries that exist on the box, somebody else who says, hey, there's a problem that's been detected, let's see if a move fixes it. And you want to limit those administrative moves across the DAG. Now, some of the reasons we also want to do this is there is the recognition that every time a database moves, whether it moves because of a failure or it moves because the administrator moved it, there is a small chance that there's client impact, right? Anytime that load shifts, the client connections have to be redirected to a different server. If the remove mailbox is in process, a different MRS has to pick up the moves because they've been relinquished from the previous host. So for the most part, although moves are completely benign, there are things that are happening in the background that might be noticeable. You also have some older clients that don't deal real well with the reconnect to CAS and the ability to get back to that mailbox. So you want to, again, use these types of policies to limit those moves. Now, the policy that you see here by the first one is the setting override. The component's high availability, the section is Active Manager, and what we're saying here is the move suppression limit. Okay? So the move suppression limit is saying allow up to 2 moves. We're going to block the third here if you were to do this. Now, by default, correct me if I'm wrong, we're allowing 4?
Allowing 3.
Allowing 3. The fourth one would be blocked. The name that you see that's specified here with the change limits is logical. It's so that you can go back and find it at a later point in time if you choose to do so. And then the reason, again, is something that you specify is logical. Now, if you want to set a period of time, for example, maybe you designate a peak period. So maybe you decide that your peak period is 7 a.m. in the morning till 6 p.m. at night. You can actually create an override for workload management that prevents moves during peak periods, and you specify a time limit. So you can see in this example here, the start time is 0800 and the end time is 1700 or 5 o'clock. Now, what I found interesting when I was kind of preparing for this is I said, okay, this is time. So I have nodes that are in Philadelphia, I have nodes that are in San Francisco, and obviously 8 a.m. in San Francisco is different than 8 a.m. in Philadelphia because of time zones. So the question was, how do we actually handle this time? And the response was, we don't, right? One of the recommendations we have here is to set your servers to UTC time. So that way the time is always the same on all servers that are running Exchange, so a policy like this would actually work. If you have your servers set to different time zones, this policy is evaluated against local server time, right? Now, that may actually work in some instances because, you know, if you, depending on how you have your DAG laid out, if you're primarily servicing users in San Francisco, well, then a move at 5 a.m. San Francisco time is not going to be as bad as a move at 8 a.m. San Francisco time. But it doesn't change the fact that that could actually shift how this works across the servers. Now, if you do need to issue an administrative move, so you decide that you're going to issue a move active mailbox database, if you are in peak time or the moves have been blocked because of the limit has been reached, you will receive an error back from the command that says the move cannot be completed. So we giving you a new switch here, the skip move suppression checks will actually allow you to override that. Very similar to things, for example, like skip client experience checks where you might want to activate a database whose index is crawling or has failed for some reason. This will allow you to override that suppression check and actually go ahead and get things up and running. Again, one of the things I want to stress, this is switchovers, not failovers. Even if you set a peak period, Even if you set an activation, a move limit of, for example, 2 or 3, this is not going to affect the automatic response of the system in response to failure. So we're not going to move a database just because you've specified this if it's necessary to maintain service. This is strictly to control and help bring to light the control of administrative moves or switchovers between the servers. When we continue on with the concepts of upgrading, obviously in the service we use a model that allows us to apply some automaticity to upgrading. Now, in order to do that, you have to build a lot of wrappers around it. You have to be able to understand server health. You have to be able to put the node into maintenance mode appropriately. When you're done, you have to bring the server back into service and validate that the component states are healthy and the server is actually ready to go. And there's a lot of automation that's around that, and unfortunately none of that really comes into the on-premises world. For the majority of the upgrades that we deal with in the on-premises world, the maintenance steps we go through, even if they're largely scripted, largely require human intervention, right? They require somebody to run the maintenance script. They require somebody to make sure the server's been drained, that the queues are okay. They require somebody to actually execute the installer itself and then interpret the results of the installer, right? Did the installer bail in the middle? So there are, though, some things that we can do to actually make this a little bit easier. One, pre-stage the installer somewhere. I'm always surprised when I end up in a support case how many people can't actually find their installation media. How they can't find where they downloaded it, they can't find where they've extracted it, or they've got like 10 different copies of CU7 on the server all extracted to different locations and we're not sure which one we're supposed to be using. So putting that in somewhere that you can get to and that you know where it's at is going to be helpful, right? You're going to need to find the server that needs to be upgraded and then find one that's ready for maintenance, okay? Those are important facts, right? If you're having, for example, a server that's experiencing a hardware failure, it's probably not a good candidate for upgrade. We probably want to fix those types of problems first and make sure that the database copies are ready to go before we drop that server into maintenance and start an upgrade process on it. We also want to understand across the DAG itself, what does our overall server health look like? Because we want to understand, if we drop this server, are we going to be lowering availability beyond a certain threshold or a point that we feel comfortable with? Now, run the maintenance script. Number 3 is an interesting topic because I would challenge most of you to actually find the end-all, be-all maintenance script. It's not really out there, right? So we do have a combination of several resources online that both are from Microsoft and from some third parties through blogs that go through and actually do a decent job of putting the node into maintenance mode. So you still have the start and stop DAG server, or start and stop
DAG member maintenance.
Thank you, scripts that you can use that will largely handle the transition of databases, changing the cluster state, pausing the node in cluster, and blocking database activation. But those scripts fail to address things like taking component states offline, how to handle transport to make sure queues are flushed. If queues are not flushing, how to alert you that the server is really not ready for maintenance and things along that nature. So you really have to build your own or really adopt something that you've been able to find online and pull it together as of right now. Running the installer, simple as running the installer, right? setup.exe/upgrade, mode:upgrade. Should go through and upgrade all the components that actually exist on that machine. It is smart enough to detect whether or not you've got a multi-role or a single-role machine and actually do the appropriate upgrade. There, it's a matter of actually watching it proceed through and interpreting failures and then dealing with those as you come with them. Probably the one thing here that I will say is that generally once you've committed yourself to step 4, you have to be committed. Okay? So if the installer makes it 60% through and fails, you've got to be committed to troubleshooting and fixing what that problem is. There's really no way to say, oh, well, 8 a.m.'s come, I didn't really get the upgrade done in time, so I'm just going to go ahead and stop. It doesn't work that way. There's no way to roll back. Once you've kind of entered this path, you need to follow it through and move forward until you're actually completed. Now, once you're completed and all the services are restarted, most of the things should come back healthy automatically. The replication service will resume copying. Log shipping should resume. Any copy and replay that needs to occur should pick up. And the one thing that we probably should have put here is you need to, maybe like step 4A is come out of maintenance, right? So once we come out of maintenance, you start resuming the ability of that server to be activated. You start taking the components out of an offline state, bringing them back online. That's when you can use your Get Server Health report to actually determine, did everything come back healthy? Is that box ready to go? Is OWA online? Is transport online? Are your database copies healthy with Get Mailbox database copy status? And then
Wouldn't you bring it out of maintenance after 5 rather than 4?
well, probably. Yeah. Thank you, Greg. Anything else? Excellent. What'd you say? Everything's awesome. And then you would actually, at step 6, you'd return to step 2 with starting with your next target. Your goal when you're doing your maintenance and your upgrades here should be to proceed through that process as quickly as possible. We really want to avoid where it's not necessary, maintaining these different versions for a long period of time, right? So in other words, if you start your upgrade on May 1st, you really want to be done by the end of the week, not by the end of the month.
Any specialty you'd recommend as far as primary, secondary, tertiary copies of databases being done first?
So I've never really applied any type of specific logic to that. Do we? I don't know if we
No.
do in the service.
No, just take one that's safe for maintenance according to Get Mailbox Server Redundancy. Don't worry about the preferences. Because you have to do them all anyway.
Now a lot of times what I see is, I see a wide varied logic come across my desk. I see people do all groups of servers in DR because if they run into an upgrade problem or something like that, they don't deem that to be a critical, it's not like 8 a.m. came, we've got to have it up by 8 a.m. for some reason. So sometimes I see that logic. Other times I'll see pairs of primaries in the primary done. So in other words, if you're using kind of that mesh, you'll pick 2 out of the mesh, you'll distribute the load here, which keeps things unbalanced, but you'll do the 2 in the center and then you'll come back. I've seen things like that, but I don't necessarily know if there's any rhyme or reason or best practice associated with it. That's what you really want to, that's the end goal. You want to accomplish in the shortest period of time. If you've got 16 nodes, you want all 16 nodes upgraded in the shortest period of time. For each DAG. Yeah, for each DAG is a boundary. Yes. Yeah. So if you've got 10 DAGs, you don't have to go get all 10 of them done at the same time per se. But if you're going to start with DAG 1, you should get DAG 1 done as soon as possible. Anything else?
No.
Excellent.
All right, so that's automating hardware repair, or making hardware repair easier, making maintenance easier, and we also want to make management easier. So we get as much of this automated as possible. So auto reseed was a feature in 2013 RTM, but we've been constantly improving it. One of the people you saw in that picture that we started with is the engineer who's responsible for keeping all of our database copies replicated. And so when they fail, for some reason that auto reseed, his feature, does not recover from, he needs to go fix them. So he's very motivated to get auto reseed up higher and higher and higher percentages. We're up to 4 nines now, where if you see a database copy failed and suspended, you have auto reseed, you have enough spares, there's a 99.99% chance that it's going to get fixed itself. The new thing in Exchange Server 2016 is a single copy on the volume failing. So most times when a disk fails, nearly all the time when a disk fails, it breaks everything within the span of a couple minutes, right? The next read for any part of the disk fails. If you start bad blocks, it applies to all of the databases very quickly. But in the file system corruption case, it can take out a single folder, and that will fail a single database copy. And so now you're left with a situation where the volume has 3 healthy database copies and 1 failed one. So auto reseed can try to resume and reseed it in place, but it can't actually fix that database folder, right? Because it's corrupt at the file system level. And so we need to decide if we should destroy the other 3 healthy copies that's on that volume, or do nothing and just leave it failed forever. So since our engineer is responsible for getting these fixed, so now we very carefully make sure that there's enough redundancy, make sure there's not going to be an availability problem, there aren't upgrades going on. We'll get that volume moved, or we'll get the databases moved to another volume so that we can reformat and get rid of the corruption. We recommend that you have about one spare per 10 database disks. That should allow you to have like about a 1-month cycle on replacing failed hardware, which should be, you can just do it on the first of the month or give it to your intern to go do for a day, a week, or something like that.
So, one of the things that I got excited about when I was preparing for this, which probably is not hugely exciting in the grand scheme of things, is the configuration-only reseeds. So we've given you a new switch with Add Mailbox Database Copy that gives you -configuration only. And what we're actually doing here is we are injecting a copy into the Active Directory. So in other words, that database has some subcopies within the configuration container. We're injecting that copy in without actually checking to see if the database is online first or forcing you to go into automatic seeding. So anytime by default you run add, we assume that after we've added the copy and we've injected that configuration object, we should immediately start the seeding process. And one of the things I kind of noticed very early on is I've had customers who they'll provision a new database and maybe they'll add that database to node 1 and they'll add it to node 2. Then they'll migrate a bunch of users into that database, but they don't do any kind of backups. They didn't have circular logging turned on. So in other words, they have the entire log stream at their disposal, including the first log, which the first log, fortunately, actually contains a create DB record. So we actually log the entire creation of the DB in the log stream. Well, when they would run Add Mailbox Database Copy, the seeding process would kick in and would seed the entire EDB file, then seed the entire catalog. So let's say the EDB file was 50 gig, the content index was another 20. So it copied 70 gigs of data across the wire, and then as soon as the seeding operation's done, the replication service goes into a resume, and it starts copying log files. Well, where does it start copying log files? From the first log that was ever found. So now, if you had 50 gigs of logs associated with the creation of that database and the migration of users into it, you ended up copying an additional 50 gig of data to the target that, in theory, you didn't really need to copy because you could just have started with E01, brought that log over, replayed the create DB, and then just started copying log files over. So one of the things that I've been able to use this for in labs, and I have not used it with any customers yet because it's not quite fully out there, is to go through and take a database where I have the first log, add the copy, and then just use the standard log shipping process to actually replay the copy and replay the logs over to create the database, therefore not having to copy data twice. Now, interestingly enough, we kind of had a support case come through last week where we had a customer who lost all the servers that hosted a copy of a given database. So they had like 8 nodes in their DAG, and simultaneously they lost 4. And those 4 servers happened to contain the copy of one database. So at one time, this group of population lost any endpoint that was valid for them. Now, what we ended up losing is we ended up losing the physical hardware. So the storage was still intact. We still had arrays. We still had the actual chassis with the disks in that we could move to another host. And what we were looking at is internally, it kind of came up in the conversation that one of the neat things about this is it doesn't actually check to see that the database is active before you inject the copy. So if you were to do Add Mailbox Database Copy with an identity and say seeding postpone today, which is another way to kind of achieve this same set of steps that I described here, you would actually have to have the copy online and mounted in order for it to work. Here, you would have just been able to inject the copy on another DAG member, swing the storage over, mount the database, and voila, you're done. Your users are back up and running, and then you could start moving storage around the other nodes. So it was kind of a creative, as we were hashing this out, it was kind of a creative use of that I would not necessarily say is mainstream. That's kind of definitely niche to lose 4 boxes at the same time, especially this 4 that just happened to host the copy of this database. But there again, something that would help in terms of how you could leverage this in the on-premises world. So, free point-in-time backups, right? The use of the lagged copy. So one of the things that we are recommending in the preferred architecture is the deployment of a lagged copy for your database. And did you specify a date range, or you pretty much leave it up to 7 days? Thank you. I couldn't remember off the top of my head. So we're recommending that you actually place a 7-day lag copy out there. The entire product is designed here to allow you to kind of travel back in time if you need to. Not only do we recommend the deployment of the lag, but we also recommend that you use the safety net feature, and that the safety net threshold should at least be what the lag time is against the given database. Yes? Correct. Yes.
Two active, or one active, two passive.
Yep, 1 active, 2 passive, 1 lag, right? You should keep symmetrical, right? So it should be symmetrical in the blocks. So if you're not going to use a lag, then you should just essentially have a 4th copy that's there. Now, there's really no reason not to use the lag because you can actually set the replay lag manager, which is the 3rd point on here. The replay lag manager will actually take a look at the status of the databases across the DAG, and if we find that you're in a position where the only other viable copy is the lag database, we'll begin to replay down the log file queues in the background so that if, for example, you were to have a massive failure, you'd either be fully up to date or at least closer than you were beforehand. So that'll give you an opportunity to use that. So if you are using lag copies, we recommend turning that on. Now, obviously the detriment of doing that is that there could be points in time in the background where log files are being played down, you're not aware of it, and now you've lost this quasi point in time backup, right?
Does that redundancy script that you guys have show a lag copy available?
Yeah, so get mailbox over redundancy does not consider a copy that's going to take 2 days to activate as available. So basically, if the replay lag queue or the replay log queue is large enough, it's not available. Yep. But it is redundant, yeah, because it does have all the data.
Now, I just have a quick question. How many people in the room have ever used a lag copy for any point of recovery? Yeah, what was the scenario? Don't be scared, throw one out. Goofing around, all right. Yep, Andy's playing in his box, so he's using it to goof around. In the support world, I've done very little lag copies, lag copy recoveries. A lot of people have them, but I haven't necessarily seen them used. The one time that I can think of that has been the most helpful is for those that have ever had somebody lose a folder. For example, a C-level user who clicks at the top-level folder and right-clicks and says delete and then empties his deleted item bin. That never happens, right? And fortunately, everything's actually in the dumpster with the exception of one thing. It's not just enough to give them the items back. The items also must magically appear in the folders that they were deleted from that shouldn't have been deleted to begin with. So, what we end up doing, it's probably the only time I have ever used a lag copy is to go back at the estimated deletion time, truncate the log series so that we could go back in and recover the folders and the folder structure instead of recovering the items from the dumpster. Bring the folder feature back? Trust me, well heard in multiple fronts. And if anything, it's something we hear and support all the time. I can't tell you where we're at on that front or if any actual work items are being done, but there's an active work item, says Ross Smith. What'd you say? What's a public folder? What'd you say? Right. That's the public folder you're talking about. Not your public folders today, for certain. But anyway, again, right, so conceptually what we're looking at here is the fact that the data is actually there, but for the replay lag, it's not actually replayed into the database, which gives you that opportunity to step back in time and actually recover something should you choose to do so. Yeah.
The lag copy, you said it's still sitting on the JBOD?
Sure.
There's no difference?
Nope.
Can you repeat the question?
Yeah, what was...
Is the lag copy just sitting on the JBOD?
Yeah, so
Yeah.
It is asking if you should use special storage configuration. No, definitely not, right? So one of our big features is that we're reducing peak IOPS reduction, and the way that works is it's only if you have a lag database copy on that volume, right? So because that's the only one that's going to delay its lag playdown. That's the only one that you've marked as being able to be behind. And so the way that that happens, and Lynn talked about it in the last session, is that it is not using, it's using barely any IOPS because it does not have to do any of those random writes into the database. So you're not going to get the IOPS savings if you don't have the leg database copy on the same sort of JBOD multiple databases per disk.
So in effect, you're basically saying out of the four, one is just kind of sitting there just getting low.
Yes, yeah.
Yeah.
So that's right. So that fourth copy, instead of playing at the 7 days ago, minute by minute, just hangs out during when it's at high peak.
You can think of lag IO as free.
Yeah.
You don't pay for it.
Yes.
No IO penalty for adding the lag.
Yep. So I'll just repeat that. There's no IO penalty for adding the leg database copy. You do get these additional scenarios, and you get those IOPS improvements, and it doesn't impact your availability because it plays down with the replay leg manager.
Question on, you asked if people use the lag copy for restores, how often does the service have to actually do a point in time recovery, not just a play of?
Yep.
A point in time recovery.
So rarely, but rarely means that we're very glad that we have it. So it's, even at our enormous scale, it's only happened a handful of times. And so there is the database corruption case that hopefully we find in the service before you guys see it, although that is a possibility. And then there's when Microsoft support or ourselves take some sort of action that we definitely should not have done and need to get everything back.
And how are you handling, I know the naughty word you just said, or I'm not allowed to say, single item retention enabled doesn't work in public folder, so if you go into the dumpster, which nice admins love to go and clean that out, is that something that you basically work in to stop that, because single item retention doesn't work in public folder? No. So if you purge the dumpster, and you don't have a lag copy of your public folder database or public folder mailbox, or they put in a ticket after.
It does.
Yep. So you want to go repeat that?
Well, Ross just said hold works in 2016.
Well, legal hold, but
It's the same concept. Single item recovery works for public folders in 2016.
Yep. So single item recovery works for public folders in 2016. Yeah.
To answer your other question, for customers that has been a problem with, generally I've seen a conversion to shared mailboxes. So especially when you go back and you take a look at what's actually being stored in there and whether or not truly a public folder was appropriate to begin with, you find that workgroup mailboxes, shared mailboxes probably tend to be more appropriate for that anyway. So I have seen some conversion over to that.
this is just a question, I'm not sure, I probably Google myself, but can a shared mailbox be seen on a mobile client?
Can a shared mailbox be seen in a mobile client?
Unless you use OA.
Yeah, unless you use OA. Yeah, no, I don't think so. I don't think you can add active sync. Yeah. Any other questions about lags?
So there was a case, I believe, in the service where someone set retention down so low that they deleted all their content about 80 days after they got it.
Yeah,
Yep.
that's correct.
That got restored through lags.
That is correct.
Okay, so moving on from automation and moving in towards making the server more available, which also is sort of automation because that means you don't have to go fix things and you're also not getting phone calls. So I wanted to briefly talk about namespaces. Ross did an excellent job on preferred architecture about namespaces, but I wanted to give you some more detail and where we're looking at going in the future. So still, we very much recommend that you use a unified namespace. That's a preferred architecture. That works best, right? That's what we're designing for and what we expect and hope that you're using. So I won't go into the details of how this works because hopefully you've seen Ross's presentation or you've read the preferred architecture or you've read his excellent blog posts. So everyone, hand of applause for Ross about that. Okay, but you may notice that we're not necessarily doing that in Exchange Online. So it is a unified namespace. I looked at Office365.com, so it's unified in that way. But we also have to support users from all over the world. So we could do bounded namespaces. That's definitely still supported. You can do unitedstates.mail.contoso.com and europe.mail.contoso.com. You can definitely do that. But let me explain what we're doing here. So you see Outlook.office365.com. This is basically I just use dig on this interface. Or you see it's CNAMED, which basically just means that DNS has changed where you're actually going to a different URL. And so that goes to our geodistribution DNS system. So it takes your source IP and finds out which state or which country or which region you're in, and then puts you into the right URL. So right now, if you're on Exchange Online, you could type outlook-namnorth.office365.com, and you'd get to that endpoint. You'd get to servers that we have in NAM North, and so that returns a dozen IP addresses of actually where our CAS services are running. So of course in Exchange Server 2016, those are also the mailbox servers. But if you're not in NAM North, you're not sitting, in North Dakota, my hometown, you'll get NAM South, or you'll get APAC West, or wherever these other regions are. And so you can dig that from all over the world. And the benefit is that you don't have to instruct people to go to apac.outlook.office365.com. So you don't have to use those bound namespace. So that is really helpful when people are traveling around the world.
Can I interject one thing?
Yeah.
If you haven't, when it comes to this, I would take a look at our documentation online, especially in the Office 365 TechNet, on how DNS actually works here. A lot of this, too, is largely dependent on who's answering the DNS query.
Yes.
So one of the issues that commonly comes across the table in support is you've got somebody who, for example, is in APAC, who is using a North America data center because their forwarding DNS requests are being sent to the United States first. Before getting an answer. So the success of this too is also largely dependent on who's answering the query.
So the source ID is the source ID. The source IP that's evaluated is the source IP of the DNS request.
That is correct, the DNS request, not the user.
Using the enhanced DNS where it's passing along just enough of the subnet to know where to do it?
I don't know off the top of my head the answer to that
Sorry,
question.
I don't know that one, but I can look it up. So here's what it logically looks like in the same sort of view that Ross uses. So a user in North America still goes to mail.contoso.com, and if your DNS provider supports this sort of logic, they get CNAME to nam.mail.contoso.com, right? And then they get to the NAM bits. Now, if you don't have this DNS provider, go ahead, keep using regional bound namespaces, or use unified namespace if that works out for you. Definitely not requiring this. It's not even our preferred architecture, but for very large customers, this can start getting useful. It's where we're going in the service. All right. So, next really cool topic, site resilience. So I'll start with Tim talking about what he's seen from the support world and what on-prem users are doing.
So one of the things I deal a lot with in the on-premises world is actually assisting with site resilient activations, right? And I loved Abram's comparison of site resilient best practices to the smoke detector, right? As you know, you should be, A, have a smoke detector, so A, have a plan. B, you should be testing it often to actually make sure that it actually works. And then when it goes off, you know what to do, right? And there's no guesswork in that, right? It's not, well, we're going to run here one time, we're going to run there another time. You actually know what the process actually is. Then when it comes time for that to go off and it comes time to execute it, you actually do it, right? And then you don't rely on somebody else to actually be the ones who are saving you. And what I find a lot in the site resilient conversations and the site resilient activations is that we're not actually practicing them, right? We're not actually doing the work. We're not actually making sure that our playbook is correct. Or we're doing things like testing in the lab, right? And the lab environment is great because it's this little microcosm that you control. Everything's controlled, and then when you actually go to do it in production, nothing works because production doesn't actually mirror the lab, right? So, one of the things I try to encourage people to do is every once in a while you kind of have to bite the bullet and decide you're actually going to do a business continuity test. And that's one of the things that the service is actually fairly in tune with, is making sure that we have that process. And I guess it would help if I was using the right slide. I'm sorry about that. So there's the smoke detector. Now, one of the stories that I often share when we talk about how is Site Resilient actually helping us and what does it do, it doesn't actually work in all scenarios, right? You may have issues, again, if you are in this bounded model where if you activate from data center A and data center B for some reason, and the users don't have some form of connection to it, well, you're kind of stuck, right? So even though your databases are online, transport's working, and everything else, you're not actually getting your users into their mailbox, and they're not able to do their work. This is especially prevalent in like the third site scenario, right? So customers who have, for example, put their file share witness in the third site, and then what's happening is the databases, for whatever reason, have activated in the remote site, but their connectivity is bound to site A. So for example, if the WAN link goes down and quorum existed in the DR site, your users are still happily connected to the primary data center. They're still trying to traverse that WAN link that's actually down, and they can't actually get to it. Additionally, you can see things in that scenario. For example, Mailflow does not work the way you want it to because the data center still has connection to the outside world. So mail is still being forwarded into that data center, but unfortunately, the transport proxy can't actually get to the other side to actually send that data to where the database is actually mounted. So you see transport issues, you see client issues, and that's why largely the unbounded model is what brings success, especially in the third site scenario. Now, the other thing I see here too, when we talk about testing and we talk about laying out these steps, is making sure that you've known how to execute them. How many people have ever run stop database availability group in order to perform a site failover, right? Yeah, do it all the time. And stop database availability group has this awesome switch in it, called AD site. And what's interesting about the AD site switch is that I see customers all the time put the wrong AD site in there. And does anybody know what happens if you put the wrong AD site in stop? What happens? Anybody? Kind of. That's a gentle way to put it. It takes all the nodes that were left and it rips the cluster service out of them, right? So then you come back along in your cookbook and you execute restore and it says, I can't do it because I can't start the cluster service. And you've taken what is something usually very simple and benign to do and have now made it a complicated problem. And this all gets back to testing and step execution. And in these cases where I see that happen, it's generally happening in the heat of battle, right? So in other words, a disaster has been declared, I'm now in there, I have to do this, and it's like, okay, stop AD site. The site we're going to is data center B, enter A all, yes, just go, and next thing you know, it just all falls apart, right? So testing, documentation, being ready to perform these steps, especially when under pressure, is important.
All right, so we've got a new feature. You may have noticed it in like 2013 SP1 called Database Copy Activation Disabled and Move Now, which is a much better option for doing DR. So I'm going to draw a couple servers, and there's the two different data centers. Everybody see that? All right. So if the normal method is you start running move active mailbox database, for each of the databases, one of them fails and you need to go look at why it did that and so on. And so in the service, we were finding that it takes like 20 minutes to do all of these sequentially, and it's not always working, and there's a lot of troubleshooting, and there's warnings thrown, and we need to go back through it, and we actually need to go do this on 100 other digs, and so it was creating a real mess. So we created this property, which is just an AD property, to, here, let me break the WAN link here, that we can set on this server, and then the PAM sees that set on the server object, and then starts moving all of the databases immediately. And it handles it on its own, it does it in parallel, and we don't have to worry about failures. So if this goes down, all of the databases, start moving over, and we don't have to run any more commands, and it all happens automatically. So that's how it gets faster. And so we've seen now, we're often doing 1,000 of site resilience events each month because we use it for network device upgrades, that it is consistently less than 1 minute. So it is, goes from 20 minutes to 1 minute, and that takes all of the actions, and the users have restored their experience much faster, or we can do the upgrades much faster. And there's another advantage to using this. If you have active passive data set, active passive, if you've got a secondary DR site, you call it a DR site and it's not active, which I wish you wouldn't do, but it's now better. So you've probably been using database copy auto activation policy of blocked, right? And that prevents any databases from ever getting there until you specify move active mailbox database, right? So a better option, instead of using that now, is you can still get automatic site resilience, with a 3 data center configuration if instead you put on the server database copy activation disabled and move now. So if you set that over here, now if this server fails or that whole site fails, the databases, instead of dismounting, are going to mount to that other server where you've got that set as a last resort. So you can still get your automatic site resilience in that case if that other site keeps the quorum. And you don't have to run the 20 move active mailbox database commands. So we recommend that you switch to using that if you've got a secondary DR site that's passive. Any questions about that?
Set mailbox.
Yep, set mailbox server.
Yeah,
so
set
it's on
mailbox
TechNet.
server.
Yep.
That'll give you the commandlet use. I don't know that this particular scenario is documented as part of, is it?
It's not documented as part of the SP1 guidance.
Sweet. Okay.
So it's on the SP1 guidance as well.
That's 2013 and 16?
Yes.
Thank you.
Good for something.
All right. So, again, I kind of talked about this a little bit ahead of time here with the stop and restore commands. Getting back to the point of having that process that is well documented and is ready to go. How many people in here actually do not do their site activations? That would be passed off to somebody else. Okay. How many people actually store their documentation on paper, for example? Yeah. How many have it written down? Let's start with that question. Right? That's fantastic. One of the things, I always laugh at this, we had a customer the other day that had a disaster, right? And they had very great documentation. They had screenshots, exact commands to be run, down to the point they could copy it, and they stored it in one place, SharePoint, right? Which was great until the entire data center was gone and the link no longer worked to take them to the documentation that they actually needed, right? So when we talk about site resiliency and we talk about these activations, not only are we looking at the processes that surround the commands we're running, what switches we should be using, but we need to be thinking more broadly about, can I actually get to the document? Can the people that are responsible for actually activating or running those commands, are they capable of running them? Do they know where to run them at? And things along that nature. One of the things that we still do have out there is the data center switchover troubleshooter. Yes, sir.
One of the things that we've done in the service is use OneNote for that kind of documentation, and you can cache it on your local machine. So you can maintain it on SharePoint, and then you can
Right.
download it to your laptop. And basically every time you log in there on a normal basis, it'll be upgraded and recurred.
So for those of you that don't know Greg Thiel, how should we refer to him? Jedi Master, Grandmaster, Greg Thiel up here. One of the things he was just sharing with the group is it's possible, for example, to use something like OneNote and actually allow OneNote to sync to your laptop so that you've got it carried with you, but you still have that document stored on some form of general repository. Another great way to handle this is to actually script it. I've seen some very successful scripts used for this that break the process down, prompt you for where you want to execute certain commands and do certain work. So that's something else. And as I was mentioning earlier, the data center switchover troubleshooter, although I have not changed it from Exchange 2010, conceptually works all the way through Exchange 2013 if you have not seen that yet. Now, you've probably heard all the great stuff about Azure support over time. A few months ago, we did start supporting the Azure File Share Witness. So that is the file server that is deployed in Windows Azure so that you can host, if you needed, a third data center through that method for those that don't already have a third data center. The setup is actually really simple as long as you can meet the base network requirements to connect to it, which is that you must be able to establish 2 independent VPN connections using the supported VPN devices that are published through Azure, right? So you're looking at, for example, Windows RAS. I think there's some Cisco solutions that'll work in there too. But you have to use one of the supported methods there. And again, the whole point in hosting the file share witness in the third data center is so that either side of the 2 data center equation has the ability to lock that witness and maintain quorum. This is what would give you your automatic site resiliency. There are people that are actually using this, and it is working very well. We actually had some in the session yesterday that had raised their hands and said they had it deployed today. So I was kind of excited to see that it's actually out there and it's actually being used. Again, the majority of success, though, is when it's used in the unbounded model. Yes, sir? It has to be, yeah. There's some other requirements there too. Again, the file server has to be a domain joined member. You also have to have domain and DNS deployed into Azure in order for it to work. And really, you're not really doing anything different there. If you possessed your own third data center, you'd have to make sure you had supported connectivity. You'd have domain controllers deployed. You would have a witness server deployed. So conceptually, it's really no different. It's just you're using our Azure service in order to host it instead of you having to go through and do that. Again, though, only feasible with the unbounded model usually. There could be some corner cases where it will work other ways. And with that, what you will have, again, is that third site arbitrator to go ahead and allow the automatic site resiliency, the automatic database failover.
All right, third major section, simpler. Don't worry, this is the shortest. We have enough time. Oh, I think we missed a slide.
Did we miss a slide?
Go ahead.
Yeah, so, I was really excited. We talk about simpler DAGs. When Windows 2012 R2 came out and we finally were able to deploy without an administrative access point, I was very excited about this. I was actually hoping that it would take off and that this would be our preference because it actually alleviates a lot of the stability problems with, for example, the cluster name object that we see in support. We're forever seeing, for example, the cluster name object being deleted or the cluster name object being disabled, its Kerberos machine account. And, when you have, for example, the AD dumpster and you can actually recover it quickly, that's simple. It's when you didn't realize it for like the next 90 days and it's gone and you can't get it back and you find out that you have to rebuild the entire cluster service to get it, that it becomes complicated. So having DAGs without administrative access points reduces some complexity. It also reduces our need to work with external components. I'm also surprised, too, I listed this here. You don't have to talk to your AD team, and you don't have to talk to your networking team. I sometimes work with customers who it's an act of Congress to get a machine account pre-staged in the directory because they have to work with 2 different other teams to get it done. Or if you want to have static IP addresses for the DAG, you have to submit a request. It has to be assigned. Or you have something where I can only have static DNS. I can't have dynamic DNS because it's some form of corporate policy. All these things play into there that don't meet the requirements of having a DAG with an administrative access point. So I was particularly excited, again, to kind of see this come through. The major concern, though, that I have overall is third-party vendor integration. We continue to have, can you flip sides for me? I can't get to working. We continue to have some questions come up about, for example, backup vendors that still insist on connecting to the DAG name and the DAG IP address in order to do some form of node enumeration. The irony of it is there's other ways to actually get that data. For example, Get Database Availability Group with -status can immediately return all the operational servers, just as easy as asking the cluster service which nodes are online. So we find out that if you are deploying DAGs without administrative access points, you sometimes have to find a creative workaround like pointing the solution to one node, which introduces a single point of failure. My favorite, find another vendor that is actually starting to support our preferred architecture, or consider using native data protection, period. That's our favorite. Well, I'm sorry, my favorite for backups if you have to use them. So, yes, but I haven't had anyone actually use it. Part of the problem that we run into is that in some of these environments where you're dealing with backup servers, you're also dealing with private backup networks, and there's not necessarily DNS that's on those networks.
No, but to get to the management endpoint, can't you get rid of the single
No, because they're using host file entries, and host file entries don't do DNS round robin. Anyway, we're almost out of time, so I don't want to belabor that point too much. So anyway, simpler DAGs, DAGs without administrative access points are exciting. Moving on to reseeds. So one of the things you've probably seen throughout this point in time here is that reseeds continue to get faster, and the method by which we do reseeds continues to become more robust. One of the things we're seeing with 2016 is the ability to get 4 to 5 times faster reseeds, and that's not the function of necessarily getting faster disks. It's a function of the fact that we've changed the way update actually works and our ability to do simultaneous asynchronous seeds. So if we look on the next slide, what we can see here is that update mailbox database copy now has a maximum seeds in parallel parameter. And one of the neat things about that is, and I see this in support right now all the time, let's say you've got 20 databases on a server and they all need to be reseeded. I always see a get mailbox database copy, pipe to update mailbox database copy, dash delete existing files. And the problem is every one of those seeds, you've got to wait for database 1, catalog 1, database 2, catalog 2. Meanwhile, 2 weeks later, you're coming back and all your databases have been reseeded. And what really stinks is when somebody closes that window and you get to start all over again, right? So I got logged out of my RDP session or whatnot. So with this is actually injecting the seed requests into the replication service, and it's telling the replication service if you've got 20 databases that need to be reseeded on the server, you can do 10 simultaneous reseeds and do them in the background. So short of the replication service terminating or you rebooting the server, those seeds are going on in the background. And additionally, Get Mailbox Database Copy Status actually has a database seed status that you can look at to see how that seed's progressing and how things are working. The Update Mailbox Database Copy for a single database has the begin seed switch, and the begin seed switch will allow you to reseed a single database asynchronously, and you would monitor it for status the same way.
I'll note that if you're trying this in your lab, you might think that it doesn't work because it first actually tries to resume.
Yeah.
So if you didn't actually physically break that volume, it's just going to fix itself immediately without doing a reseed, and it also waits 5 minutes before actually doing that reseed. But and that's because it works the same way as auto reseed, where we try to recover it as fast as possible.
What did you say? Back the times? These here?
Oh yeah. Yeah, if you have infinite CPU,
Yeah.
you could be reseeding all of them to the target immediately. But we've seen that. How?
I don't know.
I don't
for
know
just-
the specific times. Yeah.
Well, those numbers were based off of 2 terabyte databases, were they not?
Yeah, the part of the database only says how long it takes, it's the rate.
Right.
And you can just figure out how long your database size will take based on the rate.
Yeah, I mean, that's the relative rate you should be getting. So for example, if the seed source has 2 databases, you should be getting around about 24 megasecond, 12 for each database, and then 20 for each single database that spreads out.
Yep. All right. So
All
this,
right.
this is the one slide I kept from last year's MEC because it was added. It's a cool new feature that we added post RTM. It's called loose truncation, and there's 2 parts to it. There's active loose truncation and passive loose truncation. But the basic point is to not let your databases dismount and be able to sacrifice one of your 4 database copies in order to prevent it from dismounting. So if one of your disks or your servers fail, the other copies keep around all of the logs that it would need for when it comes back online. And that usually presumes that like it's a network or a power failure. So when it comes back online, it only needs to copy over the logs that it's missing. But then that means that all of these logs keeping around and not being transacted are going to fill up these disks. And so if the active copy runs out of space on its volume, it is going to change its global truncation number so that the copy that went down is now failed, and it can't come back and it needs to be reseeded because it's missing things in its log stream. And passive loose truncation works very similarly. It's just if one of your volumes runs out of space that's not the active, it just gets rid of its own logs. So in that case, the last copy that was gone is not necessarily can still be resumed from the active or the remaining passive. So your databases shouldn't dismount for this sort of scenario anymore. And we saw this in the service. We first tried to get rid of all of our stragglers. Now it happens often enough that we've got a term for it. A straggler server is one that doesn't have, that has failed upgrade or has failed its hardware repair and has been down for a long time. And we worked really hard to get rid of them and keep everything back up within 7 days. We worked really hard on that. But we sort of reached an inflection point where we stopped doing that and instead fixed the problems so that our databases weren't about to dismount. Faster failovers. I already announced that. That number comes from our actual flighting in the service. So we turned it on in one section of our service, and we're averaging about 8 seconds for a failover. And this is at load. If you have zero load, obviously it's going to be real fast, but that's actual logic. Oh, did we miss one?
I did. I'm sorry.
Yep. Anyway, 10 seconds. So continuous improvement. There's another Bruce Lee quote. Running water never grows stale. So you need to keep on flowing. And so we're continuously improving failover times, peak IOPS requirements. Meanwhile, our Exchange Online capacity keeps growing, and we are reducing the number of alerts we're getting per server. So one point there is, if you have 1,000 servers, you might get an HA alert every few months or something like that. And of course, that comes directly from us running many, many, many servers.
Oh, okay.
All right. So there are some other sessions for details about this. This Exchange Storage for Insiders was this morning already, so you missed it. But it'll be online. The slide deck is also online. It gives you details about these other back-end features. Under the Hood with DAGs was last night by Tim. It was also recorded. And we also want to promote the TAP program. If you can get early access to bits, test it out, give us feedback real early. Go down to the expo hall in the Office 365 area. You can sign up for the preview program.
And one thing I'll say, 3:15 today, right? We have the Experts Unplugged session on HA and storage. Come, ask a great question. Matt's going to give you an 8 terabyte SAS drive, correct? So I think we have 2 of them to give away at that session. So one for best storage question and one for best HA question. So feel free to come on out and join us this afternoon. That'll be a panel discussion, and we look forward to seeing you. So thank you.